to see about how a meter will be measuring some quantities. Either it can be voltage or it can be current or any parameters like that. Okay? For those things we need operating forces. How it is going to work is, if we want to measure a current, a meter will be having two leads, that is one positive and the other one will be negative. If we want to measure any current flowing through a branch, we will be connecting those two leads. We will be giving the input to the meter and the current will be entering to the meter. It will be measuring and it will be indicating through the pointer. When we give some input to the meter point will be moving from 0 to some other point for which we are going to measure. Consider I am going to measure 3 milliamps current. So this will be the current I will be giving to the meter. We have a few techniques like magnetic effect, Hall effect, thermal effect, electrostatic effect, like that. Basically what magnetic effect is, when a carrying conductor is placed in a magnetic field, it experiences a force. This is one of the principles for producing deflecting torque. This principle will be used in the meter so that when you give some current to the coil, it will be experiencing some force. That coil will be connected to the pointer through some spindle. The force experienced by that coil will be experienced by the pointer outside, so that the pointer will be moving from 0 position to some other position for which it is going to measure. In this case, your pointer has to move from 0 to 3 milliamps. This is the first point. The next one is controlling torque. Controlling torque means we have made the pointer to move from 0 position to some other position, but the pointer should not swing away the steady point. That is, your 3 milliamps will be the steady state point. Your pointer should not move away from that, or it should not be less than 3 milliamps also. The pointer should be at the steady state point of 3 milliamps. So that what this controlling torque will do is, it will produce the force that is will be equal in magnitude but opposite in direction to the deflecting torque. Yes, so that the pointer will be moving from 0 position to 3 milliamps and it will be trying to maintain that steady state point at 3 milliamps. For this controlling torque, we have so many techniques, that is spring control and gravity control. Spring control means you will have two springs on the spindle. One spring will be wounded in the clockwise direction, the other will be wounded in the anti-clockwise direction, so that when it experiences some force, the spindle also will be moving along with the pointer. So one coil will be winding, the other coil will be unwinding, so that it will be very helpful for the pointer to come back to its again 0 position. That is, when you are not giving any input to the meter, no current is flowing through the meter, you have stopped your supply, means immediately your meter has to come back to your 0 position. For that one, and also to be at the steady state position, you are going to use this controlling torque. The last one is damping torque. That is, we are going to use some mechanical systems for producing deflecting torque and the controlling torque. In both the cases, some friction will be produced or some inertial force will be existing, so that your pointer cannot move from 0 position to some other position and it will be staying at 3. There will be some oscillation around this 3, that is between 2.5 and 3.5. This is my assumption. It will be swinging. To control this oscillation, we are going for damping torque. This damping torque, it is being categorized into 3, that is under damped case, critically damped